Hello everyone. I thank you everyone for registering and attending this webinar. My name is Bandhan from GL Communications. Today I am going to present a session on LTE lab emulation and analysis. In this session we'll mainly concentrate on the components involved in the network and the flexibility of our applications to provide the test solution for this LTE lab. So let's start with just going through a LTE network architecture. So on the screen you can see we have this E node B and the complete EPC, where we are giving a GL sign, where we are going to emulate as well as analyze those particular interfaces. GL mainly deals with the core network of an LTE network. GL doesn't deal with the RF interface, so we mainly concentrate on the EPC part. As we go through the presentation, we'll see how we simulate each interfaces on the LTE network. So as I'm saying, we are simulating both control plane as well as the user plane, which is involved in a data call from LTE. So let's go through how we can achieve using our solution. So this is the complete 4G lab setup with a real E node B. So as you can see, we have a real E node B in the picture, and all the EPC elements which are named as a GL, for example MME, HSS, HGW, PDN gateway, and the web servers or a data servers. So this is one setup where we are going to attach a real mobiles or real equipments to LTE network, where initiate the data calls. It is complete data call where mobile is going to get an IP address and connect to an external network. So all the procedures which involves in getting this data enabled will be simulated by GL on the EPC side. So GL provides one more setup where it is with a simulated E node B, where we can have thousands of UVs can be simulated with a core network acting as a GL EPC. Well, now we'll go through a video which explains about how this can be achieved using GL equipments. Yeah, we can see here the entire EPC is simulated by the GL equipments. Okay, where the real equipments are going to connect to a real E node B. There we can see there are two mobiles which are connecting to the real E node B, and then to the real equipments called MME, HSS, HGW, and the PDN gateway. Okay. So we have one more product called packet scan, where we are going to analyze the complete LTE calls. We are connected it through a monitoring port, so all the analysis of this LTE network will be captured on the packet scan. So this is the remote maps, where we are going to access all the clients from a single server. Like we have MME, HGW, HSS, and the PDN gateway. So it's a single GUI which is going to provide you access to different elements in the network where our product is running. So once we start this application, we will be having an access to individual nodes. Now I'm going to start a real E node B with a pre-configured file, where we are going to configure which band to use, what is the authentication parameters for that particular UV. Okay, once the E node B is started, we have to concentrate on the EPC side. So let's begin with starting all the applications. So this screen will show you how to load the pre-configured configuration and then starting it. So now you can see the link status. This is the SCTP link status between HSS and the MME. You have an access to each of the link status in a single window, where you can you will get a drop down menu. From there you can select the link status of this HSS server now. This is at the MME side, where you will be having two HTTP links, one with eNodeB and one with HSS. As the eNodeB is already started, we have this management procedure already taken place. It is completed. Now the EPC is ready for accepting the data calls from the real equipment. You can see the signaling between eNodeB and the maps for this management procedures. Now we are going to turn on the real equipment with a 4G enabled SIM. It searches for the network, available 4G network. As you can see on the phone, you will be having this 4G indicator. So this is the call reception window of MME where the call will be received. And the signaling part you can see in this window where we are specifying the initial UV message from the eNodeB is received to the MME, where it is forwarded for authentication, and now it is going for a create session request to the SGW for creating a tunnel, data tunnel. Once the attach is completed, now the UV has got its IP address where it can initiate the data packets. It will be having an internet connection where it can browse any website, or it is, we can see we are loading this gl.com website. And this is the packet scan where whatever the call we have made will be captured and analyzed frame by frame. You can see the complete decode of a PDN connectivity request message with all the details. So this is a simple video which shows how this can be achieved. Now we'll go through the rest of the presentation, which focuses mainly on different flexibility of our applications. So these are the interfaces supported by GL with the protocol stacks, where we are supporting X2 AP, S1 AP, S6A, and on the EGTP side it will be S5, S8 and S11 interfaces. So here are the specifications used for developing these protocol stacks. Now let's see the application of the product in a real time. So we can set up a virtual real-time network simulating all the network elements which are involved in a 4G wireless lab suite, okay, which allows you to perform a load testing or a functional testing, regression testing, and even the conformance testing of a network elements, where any of the node can be replaced by a DUT and others will be acting by GL maps. So we will be providing a wraparound testing where it is a very effective testing where you will be having an access to each individual field of an network elements call flows. It can be used for testing the monitoring applications which are built to monitor the LTE network. So you can set up a lab environment and test your monitoring applications. Whereas if any DUT manufacturer, they can demonstrate their capabilities to the network service providers using our lab. Whereas even LTE lab can also be helpful in educational institutions on learning this LTE network, how the calls will be made, what are the different signaling takes place, how the data will flow through different entities in the network, and they can learn the protocols very easily. Now we'll see the different interfaces that will be simulated by GL. In this LTE network, GL supports this S1 AP control plane, S6A diameter, S11 and S5 S8 for EGTP protocol. We support the user plane, so S1U, and then it forwarded to PDN gateway and then SGI interfaces. Now let's see how this tool can be useful in testing your equipments. So there are different ways of testing it. One is a single interface simulation, where user has its own DUT as a eNodeB. He wants the network to be simulated so that he can test his own eNodeB. So we are providing only MME, which is going to simulate only S1 AP interface. where, as you can see in the diagram, MME is embedded with all other entities called EIR, SGW, HSS. So it's a single application where you can test your E node B as a GL product acting as an MME. So you can test your E node B with only single interface simulation, that is S1AP. So when we go to the next one, it's a multi-interface simulation. So how this is different? So user has DUTs called as E node B, HSS, SGW, PGW, but he want MME to be simulated. Then GL even provide this flexibility that MME can communicate with the different interfaces or different applications on the network. So now GL maps can be used to simulate this S1AP interface, S6A, S13, S5, S8 and other entities also. So it is a multi-interface simulation where maps will be communicating with different nodes in the network or with the DUTs. So single application will be having multi-protocols here. One is LTE S1 and EGTP with diameter. So it will be capable of handling the complete call whenever he is testing his DUTs. So one more way of testing is a wraparound testing, where the terminating ends will be GL maps, where MME will be getting tested with acting as an DUT, where GL maps can act as an E node B, as well as on the network side it will be SGW and the PGW gateways. So he will be testing MME. So it's a kind of wraparound testing where MME will be tested against E node B and a serving gateway. So here is a list of supported LTE features, starting from the attach, different kinds of authentication like algorithms called XOR and melange, security configurations, detach procedure, tracking area update, service request, and the establishment of default and the dedicated bearers, and the paging call. Our application supports several E node Bs with a standard S1AP interface support. We support even the handover procedures like intra-LTE, inter-LTE, and inter-RAT handovers. It supports CS fallback, where the call will be fall back to 2G or a 3G network. It supports voice over LTE. So here are the features of our applications, where maps is completely based on this message, script, and a profile based architecture, where for each protocol it will be having its own message templates, which are nothing but a real-time messages, and protocol simulation will be completely done by the scripting. So the state machine is achieved by writing a different scripts depending upon the requirements. And we have the profiles which are used for configuring the subscriber details, like what MC to be used, or different authentication parameters, and what is the IP address to be assigned to a UV, and so on. And main thing is it can simulate any node or any interface in the network. It is completely a software based architecture. And this application can even support for configuring the protocol timers. We can define the timers where you can configure different values for each timers. We have a provision to configure different access point names, different IP ranges, DNS servers, and even the QoS parameters. We have a configurable user database. As I explained, those are called as a profiles, where you will be configuring this IMSI, International Mobile Subscriber Identities, authentication parameters, and different algorithm selections, whether it's going to use XOR or melange. Coming to the user plane, we support GTPU traffic for HTTP and FTP up to 4 Gbps. with providing the statistics like total number of packets received, transmitted, what is the delay, latency, and a packet loss. One more important feature is you can have a negative scenarios for testing your DUTs. We have a report generation both in text as in PDF format. We can also even send the reports to a database, store it in the database. We can define different KPIs, that is key performance indicators. So this is a typical call flow that we are going to achieve with a complete LTE lab setup. As you can see, it is starting from the UV to PDN gateway. So the first contact point for maps application is from E node B to MME. So we can see the S1 setup request will be successful, then followed by attached procedure. We will be having this authentication procedure initiated towards HSS. Once the authentication is successful, we will be having the security mode command for it will be ciphered for the next coming messages, so nobody can tap it and analyze the call. So once security is completed, we will be having this creating of sessions from a serving gateway to a PDN gateway. Here the procedure of creating a tunnel and assigning an IP address to a mobile will be taken place. So this is we are just trying to explain a simple call flow here. We can have different calls like tracking area updates, handover procedures, and so on. Going to the next one, this is the maps tool where you can see the screen is changing as it goes across different protocols. The first one was S1 AP, then diameter, and this is the EGTP. As per this slide, you can see the framework is common across all the protocols. So it's a single framework application where GUI features or any functionality will remain the same. Only change is the protocol stack. So for all the protocols, we have the single GUI, same features across all the products. So it is easy to use and learn. And it's even provide you the flexibility of the complete call flow can be seen, and you can see the details of each individual IEs which are exchanged in the messages. Say for the create session request, on the right hand side you are seeing the EGTP layer and all the details of it, like what is the tunnel endpoint identifier, what are the MSISDN or MC. So you will be having an access to each individual field of an IE. So we have one more very powerful tool called message editor, where you can edit each individual messages. You can add the optional parameters or remove it. You can even change the values of each individual fields, like what is the type of identity, whether it is going to be a GUTI or MC, what is the value for it. So you will be having an access to individual field in the messages through this message editor. So this is about configuring the subscribers, where you can have multiple subscribers configured with the different informations like MC, authentication parameters like key, OP, and what are the RAB IDs going to be used. So now let's concentrate on how the traffic will flow through the packet switch network and how it is simulated using our mobile traffic over GTP. So maps will be acting as a client, as a simulated users, nothing but. So we will be having a gateway and the simulated web servers. So this is a setup. If I have to explain, then maps will be acting as an E node B with a simulated users. This gateway can be serving gateway as well as PDN gateway. It can traverse us through different gateways. Like here I am demonstrating with only single gateway. So here we have a pre-captured HTTP files. Say on the first client we have a gl.com.txt or a Google and then Nokia. So once the call is established, the data path is active. So we are going to play back an HTTP traffic text file. Once it reaches the gateway, it is going to forward it to a simulated web servers. So there the respective files will be get loaded again, and it is a stateful playback of HTTP. So once the respective files are loaded, it's going to respond to each request initiated by a client. Once the response is received, it's going to load a page. It is like browsing a complete website. So this is how the simulated web traffic can be achieved through the simulated clients and the web servers. And even we are coming up with a HD traffic generator where we can go up to 4 Gbps traffic with all the statistics like what is the number of packets transmitted, received, latency, delay, packet loss. So this is the protocol stack we are going to achieve once with the simulated traffic.
1000 clients is the maximum that you can achieve?
No, we can simulate more than this. Yeah, currently it is completely based on software architecture. So we are depending upon the system architecture. Like if we are going to have an Xeon server, then we can give more number of clients to be simulated. Is it clear?
Yes, thanks.
Yeah. Yeah, about this differing this HTTP responses, you want to corrupt this HTTP messages. Zaf? Hello Zaf, can you hear me? Yeah, I think currently we can corrupt the controlling messages like attach request or attach accept. Any controlling messages, we are able to insert an error or corrupt any byte of it and then send it across. On the HTTP side, currently we are not corrupting the frames, but if that is a requirement, then we can look into it and support of corrupting this HTTP responses.
But then I think there is one more question. What is the maximum throughput capacity, number of clients?
Yeah, that is all. Like we are able to go up to 4 Gbps currently.
Okay.
Yeah. Yeah. This slide explains about how the load can be generated on a LTE network. So this is a tool for generating the load where you will be having a different patterns from where the load can be generated, like fixed or a ramp. So you have to define what is the minimum call rate and the maximum call rate and define the duration for each hop. Say for a stepwise, you have to say what is the next hop and the call duration for which it has to withstand there. Yes, Jeff, I mean, we are testing on it Windows 10 and we will be concluding it very soon. Yeah, I was explaining here the load can be generated with the different patterns where you will be generating the load in terms of maximum simultaneous calls, or you will be able to achieve what is the number of calls per second you can achieve through this. Here are the few statistics windows which will be provided with maps where you can see the overall statistics. It's a kind of global statistics where you will be seeing what is the total number of calls has been made, what is the number of active calls, completed calls and the past calls, and the calls per second. Below is the pie chart where it displays the percentage of passed and failed calls. On the right hand side, you can see the statistics where you will be seeing the calls per second and simultaneous calls graph. Going to the next slide, it's going about the message statistics, where you will be having a counter for each message that is being transmitted or received. For every message that is being transmitted from a Maps application or received to a Maps application, or even you will be having a retransmission count, where if any message will be retransmitted if there is no response received for it within a particular time. So you will be having a retransmission count also. So one more important feature is scheduler, where users can schedule their own test cases and they can define the duration of test has to be run. Okay, and there are different options available for it, scheduling the test, like it can be scheduled on a daily basis, or it has to be only once it has to run and then produce the report. Mainly, it even supports how the call should be generated, whether it is a load generation or it is just a manual call generation, where you will be testing the functionality on a daily basis. And these configuration can be saved, and they can run the multiple test cases without the user intervention. So they can configure different test cases to be run and define the duration and the start time. So that will automatically start running the test and produce the results. The next feature is remote maps. As in the video we explained, remote maps is a very flexible tool where you will be having an access to a different systems where maps is running with a different nodes. So you will be having a centralized control for multiple maps applications, which you will be handling remotely. And we have the options to send even reports to the database access via the web interface. So whatever this is maps going to simulate, you can send the information about the signaling or any information about the call will be sent to a database. From there you will be having a web access to see all the information. You can analyze it offline. You can define the KPIs so that you will be sure about what is the number of calls placed on this particular MC, or how many bearers are established on this particular session. So you will be having an flexibility to define your own KPIs if the records are sent to database. This is about support of CLI functionality to integration with the maps. So maps is enhanced with command line capability, okay, where it can be integrated into an automated test environment such as Python, .NET, or a TCL, or any third-party application such as test shell, where the user has to write his own scripts to achieve this. We will be having this multi-user support and controlling multiple map servers whenever this is integrated with this command line applications. Few of the supported clients are this TCL, Python, Java, and VB clients. So this even provides the flexibility that different users can log in and access to the same maps and conduct their testing. So this is about the analyzing of LTE interfaces or LTE protocol. As you can see, this is quite complete network architecture where we are defining wherever packet scan can fit and analyze different interfaces. So you can see there are different interfaces, like if you concentrate on the LTE, it will be X2, S1 MME, S11, even the data path like S1U, S5, S8, SGIs, and if you go across S6A, S13, and the different interfaces on the 3G network. So the packet scan is a flexible tool where it will provide you the major details, like if you take a voice call, then it will be giving you the Morse codes of what is the RTP traffic and other things with graphical interfaces. If you come across GTP, it will be showing you what is the GTP packets carrying inside it. It will provide you the CDR capability, call detail records, and it can analyze all the interfaces on the LTE network. So this is a GUI of LTE protocol analyzer packet scan, where you can see a few of the LTE calls being captured. You can see the decode of each messages. So the first pane is a summary pane, the second one is the complete decoded pane, and the last one is the CDR, where you will be having call information like whether the call status is completed or not, which is the protocol. Yeah, it is going to provide you the what is the call duration, what is the destination and the originating addresses. It even provides you what is the important parameters like what is the eNode BS1 API ID, what is the IMSI numbers and different parameters. So this analysis tool can be useful in analyzing the different calls of a LTE and understanding each individual fields. The advantage is it can even provide you the offline analysis. You can save the traces and then open it offline and then analyze it. I think that's it from our side. Thank you.
So it was a question about the throughput that it can generate is 4 gigabits per second.
Yes. Yeah, it is the current. Currently, we have tested up to 4 gigabits per second, and we are trying to scale high up to 10 gigabits per second. Yes, maps can emulate the MME. Yeah, that's what. On the EPC side, we can emulate anything. So GL doesn't deal with only RF interfaces. Other than that, EPC side, we can simulate any interfaces.
So for example, you can run the labs without an MME, and you will emulate the MME to set up the call and everything. I also had a question about what is the typical server hardware you need the capacity to support that application?
Yeah, currently it depends upon what is the load you are looking for. So we generally prefer only for the functional testing or feature testing, it will be Core i7 with 8 GB RAM. If you want the load, then we are quoting Xeon servers.
Okay.
Yeah, because we will be depending upon the number of cores that system will be having to generate the load. Yeah, current implementation is LTE protocol analyzer can show you the ladder diagram of complete call, but the call has to be completed for it. It is like whenever the call is active, we are not updating the ladder diagram, but once it is completed, we are updating the ladder diagram completely. And about installing it on a virtual machine, yes, we can install it on a virtual machine.
Yeah, support, we'll provide support from all the 3 or 4 offices. We have an office in India and we have office in USA also. So support should not be a problem. We'll be able to provide technical support over the phone, email or through web chat.
Yeah, about conformance test, like we don't have the conformance suite ready. Yeah, but it is completely a script-based application, so you can write the conformance test cases through a scripting. And we are even thinking of coming up with a LTE conformance test suite. I think it is on our roadmap.
Yeah, if anybody has any questions, you can write back to us. We'll get back to you by mail. Thank you, Bandhan. Thank you, everyone.
Yeah, thank you, everyone.